Okay, welcome to the third question from the June 2011 question paper on M1. And here we have a slope with an angle alpha to the horizontal, 4 newtons pressing as a horizontal force on the ball. And I'm going to draw this over here so I can get some vectors drawn, as we need always when we do these questions. Here's our 4 Newton force on the particle. Here is the angle alpha, and I'm going to start drawing the rest of the forces acting on it. I draw this as a solid line because it's a real one. I draw this as an mg force. What other real forces are there? Definitely and always there's this real force, which I'm going to add here as r, and we don't know if there's any friction yet because we haven't read the question. So it says rough inclined plane. So there is friction, but I don't know which way to draw it yet because I haven't read the question, so I don't know if this is about to slide up or about to slide down. Depends on the mass of this in relationship with the 4 newtons. So let's have a look. Particle of weight W, so I'm going to already make a change here and call this what they've given me so that we're talking in the same terms as the question. They want me to call this W. It's held in a equilibrium on a rough inclined plane by a horizontal force of 4 newtons. So it's held in equilibrium. The force acts in a vertical plane containing a line of greatest slope of the inclined plane. The plane is inclined to the horizontal at an angle alpha, where tan alpha is 3/4. So they actually give us the angle, but they dress it up like this. Tan alpha is equal to 3/4. The coefficient of friction between the particle and the plane is 1/2. So that's all very useful information. I put it here. It's equal to 1/2, and they then tell us the key part of the question. Given that the particle is on the point of sliding down the plane, so I can now come up here and say, I know what you're doing, it's about to slide down, so friction is a maximum, meaning that R F of friction, I know that that's going to be mu times R. And since I know that mu is 1/2, I can just write this down straight away as 1/2 times the reaction force. We still don't know what the reaction force is. That depends on a bunch of other things, but we know this much. So let's see what they ask us. They say show that the magnitude of the normal reaction force that's this one up here, and the plane, between the particle and the plane, is equal to 20 newtons. So we need to find R basically. So the task that we have is to find R, and we need to show that it's about 20 newtons. Okay, so let me do some vectors here, some drawing. These are the real forces in the system. All the real forces are on there. And now we need to make sure that we split all of these into components which are going to be interesting to us or will facilitate the calculations that we want to do. So what components are useful? So what forces need breaking down and which ones don't? Well, when we're on slopes, we always do calculations in these two directions, along the slope and perpendicular to the slope. So here there are 2 forces that we need to break down into components, and 2 forces that we don't need to break down into components. What are the forces that we don't need to break up? Friction. Friction is along the plane and therefore very useful and very simple to use. We don't need to break it up. The other one is the reaction force. The reaction force is along the plane and therefore it does not need to be broken down. So that leaves us with the weight and the 4 newtons. Weight we break down as always in 2. We have W sine theta on one side. I'm just going to put it here straight away. We don't have theta here, we have alpha. This guy here is alpha, and we have W cos alpha on the other side. Those two should be okay for you by now. And we have remaining this guy. This guy is not going along the slope, so we need to split him up into the two directions that we're interested in. I continue this line because that's the direction of that force, and now I look at how I'm going to split it. So this is really not a component, that's the real force. So I'm going to just add it as a solid line. It's a real force, and we want that in the other two directions. What are the two directions we want it in? Well, use a different color. We want it in this direction, right? And we want it perpendicular, which is this one. But let's draw it up here because that will make a simpler triangle. Wanted it in this direction, where that's parallel to this. Okay, hopefully you can see that. And so we need this angle. Okay, and this direction of the slope is at alpha to the horizontal. This force is horizontal, and therefore this is easy to see that this is also alpha. Okay, that is a continuation. Along the slope is a continuation of the slope, right? Parallel to the slope is going to be parallel to the slope. So that goes up, and this is horizontal, so that's going to be alpha. Now, let's add some labels to this. If this is 4 newtons, this is going to be the hypotenuse. So hopefully you can see that I've made sure that that angle there is the right angle, and this is the hypotenuse, the longest side, which is the real force. We need to split it up, so this is 4 and the angle is that, so that's going to be the opposite, and the opposite is always the sine of the angle. And here we have 4 cos of the angle, right? So we're in business. We've got this force split up in two forces, of perpendicular and along the slope, and this force split up in parallel and perpendicular also to the slope. So now we have everything we need. We can now write down the equations that we want. Now we want R, so in order to find R we need to take into account the fact that this force of 4 newtons is pressing into this ball harder than, so the ball is pressing onto the ground harder than it would be without this 4 newtons, because some of this force, which is this here, is actually pressing it down into the floor in this direction, right? This is parallel to that, so that force here is how much of these 4 newtons are going into the slope, and therefore however much hard this is pressing down, that's how much it's going to increase the amount of force that the slope needs to do to keep that up. So R is not going to be only having to fight with and be equal to this force, it's also going to have to take into account that force there. Okay, and the key here is Newton's second law. We always use Newton's second law for these questions. F is equal to ma. We know that the particle is in equilibrium and it's not accelerating down into the slope or up away from the slope. It's in complete equilibrium in this direction, and so it's in the other, even though it's on the point of sliding, it's in equilibrium for the second. So we know that the force is going up, away, which are R, right? So the resultant force here is going to be made of the forces in one direction minus the forces in the other. And this here we know A is 0 because it's not accelerating, so we now can equate to 0 the forces acting. What are the forces? And I'm going to need a little bit more space. What are the forces acting? R on the one side and on the other, so we need to subtract from R the W cos alpha on the one hand and the force sine alpha on the other. Okay, so the difference between those two is the resultant force, and the resultant force must be 0 because it's in equilibrium. So hopefully you can see that that works okay. Now we don't know W, so we're going to need another equation in order to figure out what W is, because we're trying to look for R and we have two unknowns here. We don't know what that is, we don't know what this is. So it's not going to work. Even though we know what alpha is, we need to know W, right? So we need to keep on working. At this point, whenever we write an equation like this, you need to step back and have like a bird's eye view of what's going on and figure out whether you need any more equations or not for this part of the question. And here we do, because we don't know what R is, or W. So we have two unknowns and only one equation. We need a second equation. I'm going to label this as my equation number 1. Where's the equation number 2 going to come from? From the other direction, along the slope. What is the deal there? The same. The acceleration is going to be 0 because it's not accelerating yet. For my second equation, I'm going to have forces going up the slope equal down the slope. What are the forces going up the slope? Well, we know that it's on the point of sliding down, so we have the force of friction, which we labeled here half R. It's going up the slope. What else is going up the slope? This component here of the 4 newtons, right? This one here of the 4 newtons is 4 cos alpha, so they add together in the same direction. And from them we have to subtract the forces going down the slope, and they need to equal 0. Forces going down the slope, there's only one, W sine alpha, so it must be quite a big weight to counteract with those two, and so we have W sine alpha here. Now look what we have, 2 equations and 2 unknowns only. So that's perfect, that's all we need, and now it's all to do with our mathematical ability of how to solve these things. I suggest that you do it in such a way that you end up with sine alpha over cos alpha, right? Because we know that sine alpha over cos alpha is equal to a half. Why? Because sine alpha over cos alpha is tan alpha, right? Well, either that or you can just divide them by 2. Either way, it doesn't matter very much. Sorry, tan alpha is equal to 3/4. I said a half. Oh, sorry if I confused you there. So we can do sine over cos, or we can do, I don't know, whichever way you prefer. Here there's an r, and there's a half an r. So we can also multiply this equation by 2 and then add it to that and get rid of the r that way. That would be fine also. Okay, so let's do that. Let's get the second equation, multiply the whole thing by 2 first. So what do we get if we multiply? I write here equation 2 times 2. What do we get? Well, half r times 2 is r. 8 cos alpha is, sorry, 4 cos alpha times 2 is 8 cos alpha. This is going to be 2 W sine alpha equals 0, because 0 times 2 stays the same. Now we have r here and r there, so we can just subtract both equations and say 1 minus 2. And we get rid of the r like that. So the r minus r is 0. It's going to look ugly like that because it's got a negative there, so I'm going to subtract 2 minus 1 instead. It's going to look a little bit better. 2 minus 1. We have 4 cos alpha minus W cos alpha, so that's minus minus is a plus, W cos alpha. I just subtracted well, I'll do it all in one line so it gets a bit less confusing. Okay, so in one line it would be the r minus the r goes away, and we have 8 cos alpha minus 2 W sine alpha, that's the whole of that equation, minus that, the r disappeared with that, we already said, minus minus W cos alpha, which is from here, minus 4 sine alpha again. So that minus minus creates a plus, that equals to 0. Hopefully that makes sense. You can do it in any way that you want of combining those two equations, it doesn't really matter, there's lots of different ways. So now let's sort this out. Now we have an equation only with one variable, only with W, so we can sort it out. Okay, we have, okay, so I have W cos alpha here minus 2 W sine alpha equals minus 4 sine alpha minus 8 cos alpha. So I've passed everything to the other side that didn't have a W. Now I'll take the W outside. Go to minus 4 sine alpha minus 8 cos alpha. Now I divide, and W is going to be equal to minus 4 sine alpha minus 8 cos alpha. That's a plus, sorry, because there's a minus outside, over cos alpha minus 2 W. Oh my god, I have another W in there. I made a boo-boo, an algebraic boo-boo. That doesn't make any sense having a W there. That's because here I didn't take the common factor properly. Wow, making a little mistake, sorry guys. Taking the W out, so I should have had here 2 sine alpha. Okay, so here I should have 2 sine alpha. Okay, so now that's W. So let's find W and put it into here to find R. So inverse tan of 3/4, W tan alpha was 3/4, right? So to find alpha we just need to do tan to the -1 of 3/4. 36.9. I'm going to write it down to a few more decimal points. 0.8698. Okay, it should be a 9 actually. Degrees. So if I now come here and I type in, I'm going to save this angle there. But so we have minus 4 sine alpha is 4 times sine of we call A equal to 2.4 plus 8 cos alpha plus 8 cos we call A, 8.8 negative. 8.8 divided by cos alpha minus 2 sine alpha. So that's cos of we call A minus 2 sine we call A minus 0.4. Good sign that we get 9, no pun intended, that's a good sign. So 8.8 divided by 0.4 divided by 22 kilograms. So it was quite heavy, it was quite a heavy object. That's why 4 newtons wasn't really managing to push it up. Alright, so 22 kilos, and that was a really sort of inefficient calculation. I'm sorry, I'm a little bit tired, but the rate at which you know, if you look at the question here, the second part was to find the value W. So we already done that, and now to find the normal reaction we can just put it in the first one, and that's going to be really quick, and we got 9 marks. So even though that took a while, we've actually just got quite a lot, quite a big amount of marks or percentages. So even if you get stuck a little bit like that, if you want to go to the next question in the exam and then return to it feeling a little bit more fresh, that's fine. But you know, just plot through it, and if you know that you're doing things correctly, as long as you're careful with the signs and everything, even when you start seeing odd negative signs like that, you know, if I see a negative sign here and another one here, and then, you know, I just put brackets and I make that a plus, then I know this minus is going to make them both negative. I could have left it like that also, it doesn't matter. That's just a little bit neater mathematically. And you know, if you are careful and you watch carefully for errors that you might have as you go on, then even negative signs like that will cancel. You get always a sensible answer. So now we know what W is, which was actually the answer to part 2 in the question. We can know, and we can now come here and figure out what R is from just this one. So I'm just going to rewrite equation number 1, which is R minus W cos alpha minus 4 sine alpha equals 0. So R minus W cos alpha minus 4 sine alpha equals 0. So I know that R is equal to the addition the addition of those two. On the other side, and that's 22 times cos alpha, so I'm just going to do on my calculator. Alpha is already saved on the memory one, so I'm just saying 22 times cos of we call A equals to 17.6 plus 4 times sine of we call A is 20 exactly. So we got 20 newtons for R, which was very quick, and 22 kilos for W, and that was for 9 marks.